Okay, in this video we're going to talk about finding equations of motion. And this can seem a little tricky at first, but I'm going to show you a method that hopefully makes it a little bit easy. So in our class, we're always going to have three kinds of equations of motion. We'll have position time, which will look something like this. And I will explain this after I write it. So x of t equals 1/2 at squared plus v naught t plus x naught. And then we have our velocity time graph. Oops, let's change the color on that. There we go. We have our velocity time graph, which is equal to a t plus v naught. And then we have our acceleration time graph, which is equal to a. So in this class, our equations of motion are always going to take these forms, right? They will never be any different. And that's not because equations of motion can't be any different. It's because in our class, the acceleration time equation of motion always has constant acceleration. Okay, what I mean by constant, I'll put an example up here, is a of t might equal something like 5, or a of t might equal 2, or a of t might equal -1, or a of t might equal 0. In all of these cases, it always just equals a single number. It's constant. It's unchanging. Okay? And that fact, right, the fact that our acceleration is always constant or always unchanging means that our velocity time graph will always look something like this, right? And our position time graph will always look something like this. Okay, well, that's great, Mr. McClure, but what do all of these symbols mean? Okay. So that's what I'm going to talk about for a bit right now. So the first thing to know here is this x stands for position, right? This is not the x on the x-axis. It's a different kind of x. We're going to notice in physics and in math that some letters get overused. X is one of those letters. Sometimes x stands for x as in the x-axis. Sometimes, you might have an equation like this, y equals mx plus b, right, as in a line. This is a different kind of x. And we just have to know this from context, right? Oftentimes in my class, x will be position. Oftentimes in your math class, they're going to be talking about the x-axis. T pretty much always is time. And in this case, it is going to be time. Right? I'm sure we can find an exception, but here we have t is time. 1/2 is just the number 1/2. A is acceleration. T is again time, right? Squared, meaning this is time squared. V is velocity, but notice, right? Notice this symbol here, right? This, 0 is actually naught, V naught. And what that means, right, V0 or V naught, sometimes you'll hear it both ways, is it's not just velocity, it's velocity at 0, right? Or said a better way, it's the initial or starting velocity. Okay, so this is the initial or starting velocity. And when I give an example, I'll go to a little bit more about what I mean. T is again time. This is a plus sign. And then we have x naught, which we should be able to figure out, right? X is position. Naught just tells us, right? This is like just tells us that it's the starting, right? So let's write starting position. Okay. And we're going to keep going, and I'm going to talk about our next equation. Well, v, we already know v is velocity. T is time. A is acceleration. Right? I can save a little time. Just draw an arrow. And v naught is initial and starting velocity. And notice here in our last, our last graph, A is acceleration. The same acceleration, right? So the good news is, even though there are a lot of symbols, lots of them are reused, and at least between these three equations, right, the symbols all mean the same things, right? So if I see an A in acceleration time and I see an A in my velocity time, I know it's the same A, right? And the same goes for position time. This is the same A, right, as this A, which is the same A as this A. And T, right, this T is the same as this T, is the same as this T, it's the same as this T. Okay, so that's good news for us. Okay, so let's talk about what we need to fill in. In other words, what part of this equation, right, is the variable? And depending, kind of where you're at in your math class, or how much you remember from your math class, there's a clue. And the clue is in the left-hand side of this equation, right? So I've written x of t. I've written v of t. I've written a of t. Okay? This of, right? This t in parentheses means that t is the only variable, right? Our position only depends on t. Our velocity only depends on t. And our acceleration only depends on t. That means everything else on the right side of the equation must be filled in unless you're a t. So t is the only thing that gets to stay a letter, stay a variable. Okay, right, and you may have recognized this, right? Kind of, sometimes you would see, right, this is your slope intercept form. Sometimes your teacher would write y equals mx plus b, but they also might have written f of x is mx plus b, right? And the clue, right, that you probably didn't know when you first learned this is that x here is the only thing that gets to stay as a variable. That's why it's the f of x, a function of x, right? This tells us x, position here in this case, is a function of time. Velocity is a function of time. All right, without belaboring that a little bit too much here, let's go into an example. So, if I had a ball and I dropped it from a cliff, okay, and then I watched how far it fell after each second. Let's say, after the first second the ball was here, then here, and then boom, it hit the ground. Okay, and then I recorded, right, the only data that I could record. I recorded time and I recorded position. Okay, We'll say I record time in position, sorry, in meters, and time in seconds. Okay. And here okay, and this here I'm not saying t of s or x of m. I'm actually just indicating, oh, t, it's measured in s, which stands for seconds, and x, or position, is measured in m, which stands for meters. Okay. So another little kind of tricky notation fact. So at t equals 0, let's say it was at position 0. At t1, let's say it was at position 1. At t2, let's say it was at position 3. And at t3, let's do one more. And let's say it was at position 6. Okay. And we know in order to, or rather I'm going to tell you right now, in order to figure out your equations of motion, you're going to want to figure out your velocity, by calculating the first difference. And I have a video on how to do the second and first differences. And you're going to want to figure out your acceleration by calculating the second difference. And we know these areas are shaded. So the first difference here is 1, 2, and then 3. And then our acceleration is 1 and 1. Okay, so the acceleration equation of motion is the easiest one to figure out. If you remember, it was a of t equals a. Well, in this case, a is just 1. Okay, so we figured out our a of t just by looking at the constant acceleration. V of t, right, we'll remember is a, right? We already know a was 1, so let's write that, times t plus v naught. Well, what is v naught? Well, it turns out v naught is just what's in the very first v box, right? Our initial velocity. So our v naught is just 1. Oops. Went back a little too far. Our v naught is just plus 1. So does this equation check out? Well, our v of t, our velocity of t, equals 1 times t plus 1. Okay? The only variable that's allowed to be there is t, and the only variable that's on the right side is t. And finally, let's do our position of time. In other words, our x of t. Okay? Well, we'll recall that our x of t is 1/2 times a. Well, a was just 1. Times t squared. Well, t gets to stay there, right? Remember, t is the only thing that gets to stay there. Plus v naught. Well, we'll remember our v naught was just what's in this box, right? So v naught was 1 times t plus x naught. Well, if v naught was what's in the first v box, guess what x naught is? What's in the first x box? Plus 0. Okay, so there we have it. Our equations of motion. It's this simple, right? It's as simple as writing out x of t, v of t, a of t, the forms, and then filling in everything but the t's.